So good morning, welcome to Sakala Vidya YouTube channel. So welcome to Diploma Basic Engineering Mathematics M1 Semester 1. So we have been discussing logarithm chapter. In the last session we had a discussion up to theorems we have discussed and properties also we have discussed. So today we are going to discuss the remaining properties and we shall directly switch over to the problems. So we solved the most of the problems. That is actually, it may be 2 marks or 1 marks problems and 4 marks problems we shall discuss. So we talk about first one more property or theorem, that theorem number 7. Okay, welcome you all once again. Okay. So theorem number 7. Let us wait. Okay. Theorem number 7. If a comma m are positive Sattvic positive real numbers and a does not equal to 1. Okay, and a does not equal to 1. Then a raised to log m to the base a equal to m. So this is very important theorem. It will be useful for even higher level or m1 or m2 or m3, even m4 also. It may be engineering also, it will be useful while solving the differential. So good evening, welcome back to our session. So good evening. So now if a comma m are positive real numbers, a does not equal to 1, then a to the power of log m to the base a is equal to m. So let us prove it. So prove first, let us say log m to the base a equals to x. So this is the logarithmic form. We can change into exponential form. So that we can write like this: a raised to x is equal to m. Say equation 1. Substituting x is equal to log m to the base a in equation 1. Let us see what do we get. So now therefore we get like this: a raised to log m to the base a equals to m. So this is called logarithmic identity also. Logarithmic identity. Okay, let us do some problems now. Logarithmic identity. Examples. First example, 2 to the power of log 5 to the base 2. You can write 5. Now 3 to the power of log 20 to the base 3 is 20. So 5 to the power of log sin x to the base 5. You can write sin x. So fourth one, a to the power of log f of x to the base a. You can write f of x. Fifth one, e to the power of log f of x. Generally, we treat log f of x means base 10 or base e here, base e only. So we can write f of x. So this is very important. This is also very important. So this is the use of seventh theorem. So am I audible to you, all of you? Right. So now let us move to the next concept is logarithmic function. Logarithmic function. Logarithmic function. So what do you mean by logarithmic function? Logarithmic function, because in the examination you may be asked the question like this: define logarithmic function. So definition of the logarithmic function: let a be a positive real number and a does not equal to 1. The function f from 0, infinity to real number system are defined by see f of x equals to log x to the base a for every x belongs to 0, r 0, infinity is called a logarithmic function. Logarithmic function is called a logarithmic function. So my dear students, actually you remember that if you are asked to write the definition of logarithmic function, so you need to remember from here to here. This is called logarithmic function. So now let us discuss the graph of logarithmic function also. Graph of logarithmic function. So now graph of logarithmic function. Graph of a logarithmic function. Logarithmic function. Sometimes you may be asked to draw the graph of a rough graph of a logarithmic function. So this is x-axis, This y-axis you consider like this. Rough graph means x dash, this origin is y and y dash. So graph will be like this. So this graph is actually y is equal to log x to the base a, where a greater than 1 graph. It cuts x-axis at 1, 0. It passes through 1, 0. So this graph is actually when a greater than 1. Graph of y or f of x also we can say. Log x to the base a. This is case 1. Okay, next. So next graph, case 2 graph. This is x-axis, this is y-axis, x dash, this is origin, say y dash. Same the graph will be like this also. So this is the graph of y is equal to same log x base a, but when 0 less than a less than 1. It also cuts x-axis at 1, 0. It crosses x-axis at 1, 0. This is case 2 graph. Case 2. That means graph of y is equal to log x to the base a when 0 less than a less than 1. 2 cases. Right. So from this actually see some important points. First point. See, suppose log x to the base a equals to log y to the base a. Can we say x is equal to y? Yes, why not? We can say x is equal to y. That implies here x is equal to y. Because since bases are same, since bases are equal, or we can say same. If the bases are equal, the two logarithms are equated, the numbers are equal. X is equal to y. We can write. Second concept is important. See, if a greater than 1, base is greater than 1, then and x greater than y. If you apply the logarithm to the base a on both sides, that implies the log x to the base a greater than log y to the base a. If base is greater than 1, when you apply the logarithm to the inequality, this is called inequality, the symbol will not change. Greater than is greater than only. Lesser than means lesser than, or you can write like this also. Suppose x less than y is there, you can write same thing only. Log x to the base a less than log y to the base a. This is called inequality, logarithmic inequality. Logarithmic inequality. Suppose this is important case, need to be discussed. See, if 0 less than a less than 1 and x greater than y. Here very interesting thing, I use different color for this one. See, when you apply the logarithm both sides, you get like this. Log x to the base a, symbol reverses, greater than becomes lesser than log y to the base e. Now x less than y is there, or log x to the base a greater than log y to the base e. This is also inequality. So these are the important points you need to remember. Next, we need to discuss meaning of E. What is the meaning of E? Actually, where E is the Napier base, Napier logarithms base. Is the base of Napier logarithms. Napier is the mathematician first who introduced the logarithms. So now let us discuss meaning of E. What is the meaning of E? See, for any real number, x belongs to R, that means real number system, x belongs to R, e power x, e raised to x is called exponential function. This is called exponential function. So power series we shall get it 1 plus x upon 1 factorial plus x square by 2 factorial x cube by 3 factorial plus x to the power of 4 by 4 factorial and so on. You can write x to the power of n by n factorial plus dash dash infinity. This is called power series. This is called power series. That means e power x can be expressed as a series in terms of x. So my dear students, you remember the same e power x can be written this symbol also, sigma. Here n is equal to 0 to infinity. Here you can use this nth term, x to the power of n by n factorial. In some textbooks you may find like this also. When you go for the higher studies, you will find such symbols. Short form also we can write. This means sigma. This means summation. Summation means adding. Summation. So now you do one thing. See, let's talk about some additional information regarding to this exponential function. So we know that, are you interested? We know that e raised to x equals to, just we define 1 plus x upon 1 factorial plus x square by 2 factorial plus x cube by 3 factorial and so on, x to the power of n by n factorial plus dash dash infinity. Okay, so now put x is equal to 1. What do we get if you put x is equal to 1? You get like this, e raised to 1 equals to 1 plus 1 by 1 factorial plus 1 square by 2 factorial plus 1 cube by 3 factorial plus dash dash, you will be getting infinity, you will be getting. My dear children, I will explain what is meant by 1 factorial. 1 factorial means 1. 2 factorial means, don't get confusion, 2 into 1, 2. Now you might have expected 3 factorial. 3 factorial means 3 into 2 into 1 and so on. So now This E is equal to, we can write value of E 1 plus 1 factorial is 1 upon 1 1 plus 1 upon 2 plus 1 upon 3 factorial is 6 and dash dash infinity. See, this is equals to actually limit n tends to infinity 1 plus 1 upon n all to the power of n also is equal to E. If you simplify this value, you get E is equal to approximately equal to 2.718 28128. This is the value of E. E is called an irrational number. One more note also write down. E equals to 2.718 28128 and E is an irrational number, not rational, an irrational number. This is the meaning of E. And one more thing, similarly we have e raised to minus x, that also we can find out. 1 minus x upon 1 factorial plus x square by 2 factorial minus x cube by 3 factorial and plus so on dash dash minus 1 to the power of n x to the power of n by n factorial plus dash dash infinity. This shortly we can write sigma, here n equals to 0 to infinity, you can write minus 1 to the power of n x to the power of n by n factorial. So you remember where n factorial means n into n minus 1 into n minus 2 into and so on dash dash 3 into 2 into 1. This is the product of the first n natural numbers. N factorial means this is e power minus x. So now let us discuss graph of y is equal to e power x graph. Let us draw. Sometimes we may be asked to draw the graph of y is equal to e power x also. Graph of e power x. Okay. This is x-axis, x dash, y and y dash. This is the origin. So the graph of e power x will be like this. So this is the graph of y is equal to e power x. It crosses at 0, 1. So it will not touch the x-axis. It cuts y-axis. This is the graph of y is equal to e power x. This first graph. Okay. Next graph of y is equal to e raised to negative x. Let us draw the graph of y is equal to e raised to negative x. This origin, x and x dash, y and y dash. So this is the graph of y is equal to e power minus x. So it cuts at 1 comma 0. This is graph of y is equal to e power minus x. So if you draw like this, so this will be y is equal to e power x graph. Y is equal to e power minus x, y is equal to e power x are the images with respect to y axis. With respect to y axis, both are. Right. So now let us solve the problems. Let us solve the problems. So now we have discussed the total concept of the logarithms. So now we shall move to the switch over to the problems. Okay. Let us do first problem. Find the value of first question, log 343 to the base 7. You need to find the value of log 343 to the base 7. This kind of question definitely will appear in the examination. Please, my dear children, you need to concentrate on this one. This is very, very important. Find the value of log 343 to the base 7. Let me explain the two methods here. I will explain the two methods. First, method number 1. Method number 1. So you need not do two methods. You can adopt any one of the methods in the examination. Solution. Let us consider this log 343 to the base 7 is equal to x. We do not know the value. Say x. X value we need to find out. So this is a logarithmic form, exponential form, that we can write 7 raised to x is equal to 343. Okay. So now we have this 343 we can write from factorization. See, 7 4 ja 28, 7 5 ja 35, 28 means 63, 7 9 ja, once again 7 7 ja. That means 343 equals to, we can write 7 cube. So therefore now this is the rough part, rough work. Again this 7 power x equal to, we can write 343 is equal to 7 cube. Bases are equal. Bases are equal. Since bases are equal, powers are equated. Therefore x is equal to 3. But what is x? X is equal to log 343 to the base 7. Therefore log 343 to the base 7 equals to 3. So very simple concept. See, to which power 7 is to be raised to get 343? 7 is to be raised to 3. 7 cube is 343. So its answer is 3. This is one method. Second method, method number 2. Method number 2. Method number 2. So now consider log 343 to the base 7. So once again, rough part. 343 can be written as like this. Prime factorization, 7 4 ja 28, 7 9 ja, and 7 7 ja. 343 can be written as 7 cube. Now substitute. This equals to log of 7 cube to the base 7. We have one important result. What is the result? Log m to the power of n to the base a. This is n times log m to the base a. So this we can write 3 times 3 times log 7 to the base 7. And we have one more formula. Logarithm of a to the same base a itself is 1. Logarithm of a to the base a is 1. Log 7 to the base 7 is 1. So 3 times 1 equal to 3. So this is the answer. So now the second problem. Don't worry, second problem I will explain. Log 64 to the base 2 root 2. To the base 2 root 2. Okay, first method number 1 I will do it. Method number 1. Solution. Method number 1 or method 1. Let us say log 64 to the base 2 root 2 equal to x. Now we can write 2 root 2 whole to the power of x equals to 64. Here we can write now 2 root 2 means 2 to the power of 1 into 2 to the power of 1 by 2. So this we can write 2 to the power of 1 plus 1 by 2. 2 to the power of 2 LCM 2 plus 1. 2 to the power of 3 by 2. Now 64. 64 is 2 32 ja, 2 16 ja, 2 8 ja, 2 4 ja, again 2 2 ja. That means 64 equals to, we can write 1 2 3 4 5 6, 2 raised to 6. So now we can write like this now. See, this 2 root 2 means 2 to the power of 3 by 2 whole to the power of x equal to 64, we can write 2 to the power of 6. Next step, this is 2 to the power of 3x upon 2 equal to 2 to the power of 6. Bases are equal. So now 3x by 2, that means this must be equal to 6. Cross multiplication. 3x is equal to 12. X equal to 12 by 3. 3 1 ja, 3 4 ja. Answer is 4. Therefore, log 64 to the base 2 root 2 is 4. This is the answer. Next, second method. Method number 2. Method number 2. So consider log 64 to the base 2 root 2. See, this 64 can be written as 2 raised to 6, whereas this 2 root 2 can be written as 2 raised to 3 by 2. This we can write log of 2 raised to 6. This is 2 to the power of 3 by 2. Okay. So we have one important formula. I will give it. Log m to the power of alpha to the base a to the power of beta is there. This we can write alpha by beta log m to the base a. Here alpha means 6, beta means 3 by 2. So this we can write 6 divided by 3 by 2 into log 2 base 2. Log 2 base 2 is 1 only. This we can write 6 upon 1 into reciprocal of 3 by 2. That is 2 upon 3. Log 2 base 2 is 1. 3 1 ja, 3 2 ja. 2 into 2, 4. So answer is 4. Answer is 4. Okay, now problem number 3. Log of root over 243 to the base 3. So we need to find this value now. We need to find this value. Solution. So method 1. So method number 1. So method number 1. Let us consider log root of 243 to the base 3 equal to x. So this we can write exponential form. 3 power x is equal to root of 243. So now you check this 243 prime factorization we need to do. So 381 ja, 3 8 ja 24, 3 1 ja. Next 3 times 27 ja. Next 3 times 9 ja. Next 3 ja. So that means 243 is written as 1 in 1 2 3 4 5 1 2 3 4 5 3 raised to 5. But we need to find out root of 243. That is equal to 3 to the power of 5 whole to the power of half. Root means this is 5 into half, 5 by 2. 3 to the power of 5 by 2. So now we can write 3 raised to x is equal to 3 raised to 5 by 2. Now bases are equal. Bases are equal. So therefore x must be equal to 5 by 2. So therefore we can write now, therefore log root of 243 to the base 3 equals to 5 by 2 answer. This is the answer. So now method 2. Method 2. Consider log of root 243 to the base 3. First 243 prime factorization. Let me do once again for your better understanding. 243 is not divisible by 2. So try with 3 first of all. 3 8 ja 24, 3 1 ja 3, 3 2 ja 6, 3 2 ja 6, 21, 3 7 ja. Next 3 9 ja 27. Next 3 3 ja. So this 243 is equal to, we can write 3 raised to 5. But we need square root of 243. That means 3 to the power of 5 whole to the power of half. This is 3 raised to whole to the power of 5 by 2. So now let us replace here. This equals to log 3 to the power of 5 by 2 to the base 3. We have the formula. Log m to the power of n to the base a. We have studied the power rule, n times. So n into log m to the base a. This we can write this 5 by 2 times. So this equals to 5 by 2 times log 3 base 3. Log 3 base 3 is 1. So 5 by 2 into 1. So answer is 5 by 2. I hope you might have understood these methods now. Now fourth problem. Log of 0.0625 to the base 0.5. Solution. Method 1. Method 1. Let log of 0.0625 to the base 0.5 is equal to x. So this we can write 0.5 all to the power of x is equal to 0.0625. That means right hand side we need to express as the power of 0.5. See, the 625 factors, let us find out. Prime factorization. 5 125 ja and 5 25 ja. Again 5 5 ja. So 625 equals to 5 raised to 4. But here 1, 2, 3, 4 points is there. That means 0.0625 is nothing but 0.5 all to the power of 4. Even if you multiply 0.5 into 0.5 into 0.5 into 0.5, see, actually 5 to the power of 4 is 625. How many points? 1, 2, 3, 4 points. You get same thing itself only. So now we can write 0.5 all to the power of x equals to 0.5 all to the power of 4. So bases are equal. So powers are equated. So that means x is equal to 4. So therefore log 0.0625 to the base 0.5 is equal to 4. This is the answer. Let us move to the method number 2 for this one. So method number 2. So method 2. So consider log of 0.0625 to the base 0.5. So here we know that 625 can be written in a prime factorization form like this: 5 125 ja and 5 25 times, again 5 5 ja. So since 625 equals to 5 raised to 4, the 0.0625 becomes 0.5 all to the power of 4. You remember this technique. So now instead of 0.0625, write down 0.5 all to the power of 4. This we can write log 0.5 all to the power of 4 base 0.5. So we have one formula, log m to the power of n to the base a, power rule. This is n times log m to the base a. So we can write 4 times, 4 comes like this. So this we can write 4 times log 0.5 to the base 0.5. Obviously it will be 1. So 4 times 1, answer is 4. Now, fifth question. Log of 0.0121, 0.11, 0.11. Solution. Method 1. Let us say log 0.0121 0.11. See, this 121 is nothing but 11 square, 11 into 11. So 0.0121 is nothing but 0.11 square. Okay, let us say this is x. Now we can write 0.11 all to the power of x is equal to 0.0121. So 0.0121 can be replaced by 0.11 square. So you get like this. So now 0.11 all to the power of x is equal to 0.11 whole square. Bases are equal now. Bases are equal. So exponents are equated. So x is equal to 2. X means what does it represent? Therefore log of 0.0121 to the base 0.11 equal to 2. It's proved. Now method number 2. Method 2. So consider, so this value need to be evaluated. Log of 0.0121 to the base 0.11. So this can be written as 0.11 square. Log of 0.11 square to the base 0.11. So we have the formula. Log m to the power of n to the base a. That is n times log m to the base a. This is 2 times log of 0.11 to the base 0.11. This is 1. 2 into 1 is 2. Answer is 2. Okay. So tomorrow we shall continue remaining problems. We shall do remaining problems. Okay. Example 2 problems. Thank you. Bye bye.